All right, elementary algebra. Let's do this. So get ready to factor. So here's our last exam. I made this one pretty simple. So first step is you look at the numbers, all right? Is there a number that we can divide out of all of those? Yeah, 3 should work. So now let's look at the letters, right? So if we know we could pull a 3 out, let's put a 3 right there. Now is there, let's see, this one doesn't have any x's. So that means we can't factor an x out of all of them. Yeah, this one has 2, this one has 1, but that one didn't have any. So we can't get any x's out. So all we could pull out is a 3. So to get a 3x squared, we'd have to multiply the 3 times an x squared. That gives us the 3x squared. Now to give us a positive 9x from a 3, we'd have to multiply that 3 by a positive 3x. You see, there's our 9 and there's our x, and that gives us this term. And now for the 27, to get 27 from 3, we'd have to multiply the 3 by 9, right? So 9 times 3 is 27. So that's the best we can really do with what we've been taught so far as factoring, okay? All right. So now this one is a little more complicated. If we look at, yeah, we can get a 2 out of the numbers, right? So we could pull a 2 out. So we'll put a 2 right there, right? We'll do this one step by step though, instead of all in one. See, we did this in one big step. We could have broken that down into 2. Here, I'll just write a 2 over here for now, just kind of in a cloud. All right, a 2. Now if we look at our x's, this one has 4 x's, this one has 2 x's, and this one has 2 x's. So we can get an x squared out. So we'll put an x squared because they all have at least an x squared. Now, if we look at the y's, this one has 4, this one has 2, but this one only has 1. So the most y's we can get out is a single y. All right. So this is the thing that's in common with all 3 of these things. They all have at least a 2, at least an x squared, and at least a y. So let's rewrite this guy here in terms of this. We'd say 2x squared y. Now, what do we multiply this by in order to get this? Well, we have the 2, we have the y, but we need an x squared. We need 2 x's, right? So we'll put x squared here, okay? So this times this gives us this. So now we're going to use the same thing again, because we know this is in common with all of these terms. So to get this, we need to multiply this by something. We need to multiply it by at least a 2 so that we get the 4 here. Now we already have the x squared. Yeah, a single y will work, right? Because we have 1 y, but we need 2 of them. So we'll put a y here. I'll move my thought cloud. All right, so now for the last term. All right, so we're trying to get this from this. So we're going to need to multiply this thing by a 4. So that'll give us the 8, right? And yeah, we got x squared. And so we don't need any x's, but we only have 1 y here. And we need 4 of them. So we need to multiply this thing by a y cubed. All right, so looking at this, you can see that everything, and we did this on purpose, everything is being multiplied by a 2x squared y. So we have a 2x squared y, and that thing is being multiplied by an x squared and a 2y and a 4y cubed. All right, So we factored this. This is the same thing as this. That's why we have equals here. You see, if we multiply this times this, we get this term. We multiply this times this, we get this term. If we multiply this times this, we get that term. Okay, so that's the step-by-step breakdown. This number one here, we could have thrown in another step in here. We could have said, let me put this down here. So we factored out a 3, right? So our intermediate step, I would have written this as 3 times x squared plus a 3 times 3x plus a 3 times 9. You see, we have that 3 out front. Okay, and then here's each of the other terms. All right, so if we were going to break it down, put that extra step in there, okay? Sometimes putting that extra step makes it more difficult. You know, sometimes it makes it easier, so I wanted to do it both ways. Okay. All right, so that was your exam. Hope I remembered to, yeah. So let's do a quiz. Number 24. We'll do some more. Is that what we were doing last time? Let me see. What was 14.1? Greatest common factor. Now let's just do factor. So number one, let's look at see 2 x to the 4th y to the 4th plus 6 x cubed y cubed plus 8 x y. So here's your number one, and let's do a number 2 here. Let's do 3 x to the 4th y to the 5th plus 12 x squared y squared plus 15 x y cubed. There we go. So let's take see, I think we do these in 10 minutes. So 219, yeah, we'll do 220. We'll round it. It's like 12 minutes. We'll work these together. So out there in Zoom land, Nando's out there. What's up, Nando? All right, so these are just like the last ones. If we look at the numbers here, start off by the numbers. We'll make our thought bubble over here. All right. So if we look at the numbers, the biggest number that we can pull out of all three of those is 2. All right. 2 divides all of them. All right. So I'm going to put a 2 over here. Now, if we look at our x's, this one has 4, this one has 3, but this only has 1 x. So the most number of x's we can pull out is just 1 x. Now we look at our y's. This one has 4, this one has 3, but again, this last one only has 1. So the most number of x's we could pull out is 1. So this would be the GCF, greatest common factor, out of all of these. Okay. So we're going to take everything and we're going to rewrite everything as a product of 2xy times whatever we need to get each term. So for this first term, we only have 1 x here, but we need 4. So we need 3 more x's. We need an x cubed there. We only have 1 y, but we need 4 of them. So we need a y cubed. So that'll take care of the first term. So the second term, again, we use our 2xy here, but we need to get this. So we're gonna need a 3. So the 2 and the 3 will give us that 6 back. We only have one X, but we need 3 of them. So we need 2 more here. We only have one Y, but we need 3 of them. So we're gonna need 2 more. Okay, I can get rid of this now. And now for the last term, we have this 2xy. Yeah, all we need is a 4, right? We have the X, we have the Y. We just needed that 4 to give us an 8, right? So we have equality here. So this is equal to this. So now since everything is multiplied by this 2xy, right? We can factor out the 2xy. And what we're left with is these 3 terms inside of here. We have an x cubed, y cubed. We have the 3x squared, y squared right there. And then we have a 4. Boom, factored, right? And you have to follow it up with boom, factored, and practice your touchdown dance. So let's look at number 3 here. We'll put our thought bubble over here. We're going to find our GCF, right? So the biggest number I can get out of these numbers is 3. They're all divisible by 3. So I'm going to have a 3 here. Now for the X's, I got 4 here, 2 here, but I only have 1 there. So the most number of X's I can pull out is a single X. For the Y's, I got 5 here, 3 here, but I only have 2 there. So the most number of Y's I can pull out is 2 of them. So I'm going to rewrite each of these terms as this times whatever I need. So I got a 3xy squared. So to get this first term, I already have the 3. I'm going to need an x cubed because I only have an x. And I only have 2 y's, but I need 5 of them. So I need a y cubed. So now this is the same as this. Now for this term, again, I start off with this guy. The positive, that guy. But to get a 12 here, I need to multiply this 3 times a 4. Okay. Now for the x's, I got 1 x, but I need 2 x's, so I need to throw in another x. And I'm good on the y's. I have all the y's I need. So I have this thing still. We can get rid of this over here. For this last term, I have a 3. So I'm going to need a 5 to give me that 15. I have the x, so I don't need any more x's. I got 2 y's, but I need 3, so I need to throw a y in here. Okay. So now everything is being multiplied by a 3y squared, 3xy squared. So now I can actually do my factoring. I have this thing times this. And this. And this. And we could check our work. If we multiply this times this, you get that. If I multiply this times this, I get that. If I multiply this times this, I get that. So there's your factoring. And then we say what? Boom, factored. And we do our touchdown dance. All right, so let's see. We are in Alex. There's Alex. Okay. Look. Oh. Hole in my shirt. Bummer. Okay, so we did 14.1 last time. So now 14.2 on page 830. Throw that in here. Factoring trinomials with a leading coefficient of 1. Trinomial means we're looking at x cubed. Okay, and the leading coefficient of 1. So we're looking at stuff that looks like this. Bx squared plus cx plus d, where b, c, and d are numbers. So examples would be x cubed plus 2x squared plus 3x plus 4, or x cubed plus 7x squared plus 6. Those are examples of trinomials with leading coefficient of 1. Let's see. So we have already learned how to multiply two binomials. We also saw that such a product often results in a trinomial. For example, if we multiply, these are both binomials because there's two terms, right? So this is a binomial, this is a binomial. And when we multiply them, you get the x times the x, you get the 7x, you get 3x, and you get a 21. And then you kind of combine those to give you the 10x. Okay, so you get an x squared and keep the 21. All right, so the sum of the inner products, they didn't write this out, but what we're doing here is we have x times this thing plus 3 times this thing. So you get an x times an x, and then the 7x, and then the 3x, and the 21, right? They skipped this step. Okay, they went straight to that. Okay, so that's the step that they skipped. Okay, because you can kind of do it in your head by now. So what we want to do now is go backwards. If we're given this, we want to be able to rewrite that as this. And you know what, I told you wrong up here. These aren't trinomials. These a trinomial. I went one power higher. A trinomial only goes up to x squared. So let's try this again. Trinomial looks like this. X squared plus bx plus c. Remember I used to go ax squared? Well, they're saying leading coefficient of 1. Right, so these are trinomials because there's 3 thingies. Okay, so let's correct that. So examples are x squared plus 2x plus 3, x squared plus 2, x squared plus 7x plus 9. These are all trinomials with a leading coefficient of 1. There's a 1 in front of all these trinomials. So it's a lot easier than powers of 3, right? If you have powers of 2, the fundamental theorem of algebra says that this is going to look something like this. X, X, and you're going to have a number here, and you're going to have a different number here. All right, it's what they always look like. All right, so we turn a trinomial into 2 binomials multiplied together. That's what this section is about. Okay, so we want to be able to look at this and write that down. All right, so we already know the answer, but let's think about it. How would we just eyeball this guy? I would say this is equal to something times something. I'm looking at this and I know I need an x and an x because that'll give me the x squared, right? But everything's positive, pluses and pluses. So I know I can have pluses here. I need two numbers that multiply to give me 21, but they have to add to give me 10, right? Because you have this, right? You can see it's 3 and 7. You know it's going to be 3 and 7 because that gives you the 21, but you're going to get a 3x and a 7x as well. And those have to add to give you that middle term. So the way you do this is you always, because there's always just an x squared, we're not going to have a number out front like a 2 or a 3. It's always going to be an x and an x. And then you got to find two numbers that multiply to give you that, but add to give you this. It gets a little more complicated when they throw minus signs in there, but it's not that bad. Okay. All right. So we want to factor it as the product of two binomials. All right. So we begin our study where the leading coefficient is 1. So that makes it easy. Okay. All right. So they throw in these P and Q, right? So for us, the P and the Q are 3 and 7. We're just giving these numbers names, P and Q. So let's see here. The way they describe it in Math Geek Talk here is here's your trinomial. This is the most generic thing. We want to rewrite it as x plus something times x plus something. A while ago, I said it's a number and another number, right? We'll just call them P and Q, okay? So this number, a while ago, it was 21, right? And this was a 10x, okay? We said, okay, well, 21, we can use 7 and 3, okay? And we had the 7x and the 3x here. So this is the example before. Our P and our Q were 7 and 3, okay? So it always looks like this. This is our 21. I mean, yeah, 21. P times Q is 21. And here was our 7 plus our 3 times x. This was our 10x. Okay. So this is what it looks like mathematically using letters to do the general case. So this is what every single problem looks like in terms of P and Q instead of 21 and 10. Okay. So let's look at this one. We need to factor this guy. So x squared, we know we need an x and an x. Now we need, see, they threw in a minus here, all right? So we need a number here and we need a number here, and they have to multiply to give us a negative number. That tells us one of these has to be positive and one of these has to be negative. Because if you multiply a positive and a positive, you get a positive, but that's a negative. If we had minus and a negative times a negative would give us a positive, all right? So we need a negative number. So we need one of these numbers has to be positive. One of them has to be negative. So if we think about all the possibilities, we could be like 45 times -1. That would give me a -45, right? But they don't add to give me a +4. See what I mean? We have to think all the different ones. I'd look at like 9, let's say -9 and 5. They multiply to give me -45, right? But they add to give me a -4. We need to get a +4. So instead of that one, let's do 9 and -5. So if I did a +9 and a -5, that times that gives me the -45. That gives me a +9x minus 5x. So 9 minus 5 is 4. Okay. So if you want to check your work, we have x times x minus 5, and we have a 9 times x minus 5. So this gives us our x squared, our minus 5x, our 9x, and our minus 45. So there's our x squared, there's our minus 45, and these middle terms give us the 4x. Okay. So we're gonna do lots of these. These are ones where you can eyeball it, basically. So let's do lots and lots and lots of examples here. Okay, this one. So we know it looks like this. We know we need an x and an x because that's going to give us x squared. I need two numbers that multiply to give us negative 14, but add to give us negative 5. So if we think about all the numbers that multiply to give us negative 14, we got negative 14 times 1, or 1 times negative 14, but they don't add to give me negative 5. So I keep going. What about 2 times negative 7? Those work. They multiply to give me this, but they add to give me that. So I know I need a positive 2 and a negative 7. All right, if we check, we got x squared minus 7x plus 2x minus 14. So there's the x squared, there's the minus 14, and those give us the middle term. Okay. Multiplication of polynomials is commutative. Therefore, in example 1, we can express the factorization. You can basically, it just means you can turn it around, right? You could put the x minus 5 second. It's because a times b is the same thing as b times a. That's what they mean by multiplication is commutative. You can switch the order, it doesn't matter. Higher level math, that's not always the case, right? When you're multiplying different kinds of objects, because here we use numbers, but in higher level math, you can multiply matrices or dinosaurs or unicorns, and they all have different properties. Okay. So again, this is a trinomial. That's a generic form. We want to do this one specifically. So we have w's here instead of x's. No big deal. A w times a w gives us a w squared. So we need two numbers that multiply to give us 50, but add to give us a negative 15. So in this case, we're going to need two negative numbers because they multiply to give us a positive, but a negative plus a negative will give us a negative. Okay. So that's where we looking at the signs there. All right, because this one's negative, that one's positive. This one's positive, so we need a negative times a negative, because you can't add a positive to a positive to get a negative number. So yeah, you got 1, -1, and negative 50, but those don't add to be negative 15, right? Come again? Yeah, let's do negative 10 and negative 5. They multiply to give us positive 50, but they add to give us negative 15. So negative 10, then negative 5. If we check our work, we got a w squared minus 5w minus 10w and then positive 50. So there's our w squared, there's our 50, and these give us our minus 15 w's. It's not too bad, right? Not yet. Okay, let's see here. Okay, now they use z. Big deal. Z. All right, so this is the same thing. This thing's negative, but this one's positive. So we're going to need two negative numbers. All right, so if we think about everything that multiplies to be 48, and again, we're aiming for two numbers that add to be a negative 16. So what? -2 and -24 give us 48, but they don't add to be 16. What else do we got? I have to use my calculator. Calculator. 4 and 12. We use -4 and -12. Those multiply to give me 48, a positive 48, but they add to give me a -16. So we need a -4 and a -12. We check our work. Z squared minus 12z minus 4z, a positive 48. There's our z squared, there's our 48, and these give us our -16. Practice will help you become proficient in factoring polynomials. As you do your homework, keep these important guidelines in mind. To factor a trinomial, write the trinomial in descending order, right? It's important that you put it your squared thing first, and then the not squared thing, and then the number by itself. Put it in descending order, okay? And factor out the GCF first. So like we did up here, let's say this thing, if you're looking at this and they want you to factor it, see how there's a 3 there? You factor the 3 out first. Then you look at this and you'd want to factor that second, okay? So before, these are all easy because there is no number out front, right? In front of the squared term. But if there is, you want to be able to factor that out of all of them. Okay, and we'll do examples of that. So they're just throwing in an extra step that you do first. So here's a bunch of rules. So if the signs are bugging you, you can memorize all of this instead of understanding it. All right. So same signs, case 1, they're both positive, right? Both positive. So these are both positive. Over here, if this is negative and that one's positive, then these both have to be negative, because a negative times a negative gives you a positive, but they add to give you a negative. Now, what if we had the other example where this is negative, but that's positive, right? Well, one of these has to be positive and one of these has to be negative, because a positive times a negative gives you a negative, okay? And then they can add to either give you a positive or a negative. So here, they're both negative. Well, one of them has to be positive and negative, okay? Because the positive times a negative is a negative. And they can add to either give you a positive or a negative. So if this thing is negative, you have to have different signs, because a positive times a negative gives you a negative. But if you add them, depending on which number is bigger, you can either get a positive or a negative. You see, they have the same numbers here, 7 and 5, 7 and 5. If you make the 7 positive and the 5 negative, you get a +2. If you make the 7 negative and the 5 positive, you get a -2. Okay. All right, let's see. All right, let's do an example, and then we'll listen to what this lady says. So this one is a little more complicated. Look, the only thing that makes this more complicated is they rearranged it, right? You want to put your highest power first, and then your second highest power, and then your lowest power. So put it in order. And now factor. So we need p's here. That gives us our p squared. We need 2 numbers that multiply to be 48, but -48. So that means one of these has to be positive and one has to be negative, okay, to get a negative number here. And they need to add to give us -8. So if we start thinking of all the numbers that multiply to give us 48, and we make one of them negative, what, 12 and -4. That gives me -48, but they add to give me 8. Right? I need them to add to give me -8. So what if I did -12 and a +4? They multiply to give me -48, but now these two add to give me a -8. So that means I need my 12 to be negative and my 4 to be positive. If we check our work, p squared minus 12p positive 4p and minus 48. So there's that one, and these two give me that one. This one has another step. So let's put this thing in order from descending order. So our highest power of t is first, and then we have our second highest power, and then our third. So notice this is a cubed in it, and there's a number out front. All right, so this is where we have to do what we did on the exam and the quiz. The first thing we want to do is factor out our GCF. Every one of these has a 10, right? So I could pull a 10 out of all of those. And all of these have at least a t as well. So I can factor out the t. So to get a 10t cubed from a 10t, I need a t squared. See, this times this gives me this. And now this one, I need a -3t. There's my -30, and there's my t squared. See that? And then this last term, I'd need a -4. There's my -40, and I have a t. So first step is pull out your GCF. So now that we have a 10t out here, this guy can be factored. Okay, so now we reduced it to the problem that we're used to. You just put a t and a t. We need two numbers that multiply to give us -4. That means one has to be positive, one has to be negative, but they have to add to give us -3. So we would do a -4 and a +1. That gives me my -4. I have -4t's plus 1t. That gives me -3t. All right, you'll see that this one has 3 factors because we had a t cubed. It's the fundamental theorem of algebra. If there was a t to the 7th, when we factored it, there would be 7 factors. Okay, which means if we set this equal to 0, there would be 3 solutions. All we would do is set each of these factors equal to 0. If we were solving an equation, we're not, but if we were solving this, if I plugged a 1 in for t, this is 0. No, I'm sorry, -1. If I plugged a -1 in for t everywhere, this is 0. -1 plus 1 is 0. It doesn't matter what these are. 0 times anything is 0. That's why we want to factor, is so that we can solve equations. Okay, because if you have this equal to 0, you could say, 4 is a solution, because if I put a 4 in there for t, I get 0, and it doesn't matter what this is. 0 times anything is 0. So when it's factored, you can look at it and just see the answers, right? If I have this equal to 0 and I ask you what t's make this equation equal to 0, I have no idea, right? But if I rewrite it like this, I could tell you, well, a 4 would work, a -1 would work, or a 0 would work. So when it's factored, the solutions are obvious. That's why we're factoring. That's why we're learning how to factor. So let's look at these. Okay, first thing, put them in order, right? We need the highest power, the second highest power, and then the lowest power. All right, we don't have any numbers out here. There's nothing we can factor out. All right, so we can go straight to this step. We need a W and a W. This is negative. So we know one of these has to be positive and one has to be negative. So positive times a negative is a negative. And we need two numbers that multiply to give us -6, but add to give us -5. So that would be a -6 and a +1. There's our -6. We get -6W plus 1W gives us our -5W. All right, this one, it's all out of whack. Let's see, we have a y to the 4th here, so let's put that one first. Then we have a 30y cubed, and then 112y squared. So first step, put it in order, descending order. Next step, pull out your GCF here, all right? Every one of these numbers is divisible by 2. So let's pull a 2 out. And every one of these has at least a y squared. So let's pull a y squared out. So if we pull a y squared out of each of these terms, for the first term, I need a y squared. See, this times that gives me that. To get the 30y cubed from this, I need 15y. There's the 30, there's the y cubed. And now 112 divided by 2 is 56. So 2 times 56 is 112, and I have my y squared. So first step, pull out your GCF. Now we can take this guy and we can eyeball it. We need a y and a y to give us our y squared. This is positive and that's positive, so both of these are going to be positive. So I need two numbers that multiply to give me 56, but add to be 15. And I don't know what they would be. Let's see. So I just start with looking at numbers. 56 times 1, they don't add to give me 15. 2 and 28 multiply to give me 56, but they don't add to be 15. 56 divided by 4. 4 and 14 multiply to give me 56, but they don't add to give me 15. So let's see, 56 divided by 5, 6. 56 divided by 7. 7 and 8. 7 times 8 is 56, and they add to give me 15. So that thing is fully factored now. Okay. Is this making any sense? Kinda. It's just a lot of practice to make it easy. All right, now they're going to throw a minus sign out front. See how they're slowly making them a little more difficult. All right, we have to cover all the possibilities. All right, at least they're in order. They're in descending order. If there's a minus sign out front, just pull the minus sign out. Factor it out like you did with the GCF. This is a squared. Then we need a -6a and then a +8, right? Negative a squared, a negative makes a positive, and then a -8. All right. So that's how you deal with having that minus sign out front. You just pull it out first. So we still have this minus sign, but this we could factor. There's a squared, so we'll have an a and an a. Now for these, this is negative, but that's positive. So these both have to be negative. A negative times a negative give me a positive, but they add to give me a negative. So two numbers that multiply to give me a +8, but add to give me -6 would be a -4 and a -2, right? So there's my +8. I got -4a, -2a, give me a -6a. And then we have this minus sign that we pulled out, right? So the trick is you don't just write a minus and put it in front of all that, right? We had to change the sign of everything inside, right? right? Here's a positive, this now is negative. This was negative, this now is positive. Because you distribute this minus sign to everything, okay? So this one, now this one has two different letters. All right. Well, big deal. All right. That doesn't matter. Let's look at the numbers and the minus sign first. This minus sign sucks. So we're going to factor out a minus sign from everything. And notice everything is divisible by 2. So we're going to pull a -2 out of everything. So we need a c squared. So there's our -2c squared. This term, we'd need a positive 11, because that gives me -22. And I need the c and the d still. And now for this last term, I'd need a positive 30 d squared. Okay, so everything in here is positive now because I pulled the minus sign out front. And everything is half as big as it was before because I pulled the 2 out. So now this looks like something we could do. We have a -2. Just because there's d's in there, that doesn't make any difference, okay? It doesn't change anything. We still need a c and a c to get a c squared, right? This is positive, that's positive, so these are both positive. So what we need is two things that multiply together. Let's look at our numbers first. All right, we need two numbers that multiply to give us 30, but add to give us an 11. Let's see. Not 10 and 3. 5 and 6, right? So put a 5 and a 6. They multiply to give me 30, and they add to give me 11. But we have this d squared here. Well, big deal. What if I just put a d right here and right here? There's my d squared, right? This times this gives me 30d squared. And what do you know? This is a c times a d. Well, look. This one gives you 5 CDs. This one gives us 6 CDs. 5 and 6 give us 11 CDs. All right. This only works because this has C and D, right? This would have to be a D squared. This would have to be a C squared. And this has to be a mix of the two because of how you multiply, right? When you multiply this one times that one, you get a CD. And this one times that one, you get a CD. Okay. So just because there's more letters in there, that doesn't make it any more difficult. Okay. So let's throw in a quiz. And now let's factor. Oh yeah, it's exam. Factor. Let's see, I should write it out. Right. Factor the trinomial into two binomials, like we've been doing, okay? So if I do, let's see, if I have an x squared plus 2x plus 4, all right? And all right. No, it needs to be a 4x. No. Hold on. I gotta do something real quick. I have to reverse engineer. Problem. Yeah, that's right. And if I do x minus 1 times x plus 3, minus This is, okay. X squared plus 2x minus 3. That'll work. And we're back. All right. So yeah, factor those. Well, this thing comes back on. There we go. So we'll take a break. We'll resume at say 3:12. All right. All right. Okay. Did we do these? Yeah, we did that. Okay, we did those. All right, let's see. Let's snapshot. This. Okay. And, oh, we're recording. Okay. Okay, so let's see here. This one has this minus sign, right? So that's not a problem though. We know what to do with the minus sign. We'll just factor the minus sign out of everything. So if we do that, we have to be careful because everything else has to switch sign, right? Because the negative negative gives us our positive x, and the negative negative gives us our positive 12. So now we got this minus sign out front, but the rest of this, we can do our little trick here. Yeah, we need an x times an x to get us our x squared. This is negative, so we know we need a positive and a negative. Because a positive times a negative gives us a negative. So now we need two numbers that multiply to give us negative 12, but add to give us a negative 1. So 4 and 3, I think. So where do we put the 4 and where do we put the 3? We need to get a negative 1, so we need to make the 4 negative and the 3 positive. Okay, that gives us our negative 12. Boom. We have a positive 3x, but the negative 4x gives us our negative x there. So now it's factored. So don't forget that minus sign. This one has a minus out front. There's also a number out front, but that's okay. Right? We're going to just factor out the GCF. Everything here is divisible by -3. So let's pull out a -3. As far as the A's, this one doesn't have any A's, so we can't pull out any A's. This one doesn't have any B's, so we can't pull out any B's. We're just going to pull out a -3 out of all of these things. So we need an A squared. There's our -3a squared. Now to get the 15ab, it's positive, so I need a -5ab. There's the positive 15, and then the A and the B. Now for the last term, it's a -12. I have a -3, so I need a +4. That gives me the -12, but I also need this b squared. Okay, so that gives me this term, that gives me this term, and that gives me this term. Okay, so now this is going to be equal to a -3, and now we're going to take this and bust it up. And don't worry about the fact that there's A's and B's. That's okay. We know that we need an A and an A to get our A squared. This thing has A's and B's together, and that's a good thing, okay? All right, because we know we're going to need a B and a B over here to give us our B squared, but we need a number in front. Okay. So because there's A's and B's, it's not a problem, okay? Let's look at our numbers. We have a +4, but this is negative. So that means these both have to be negative because a negative times a negative gives us a positive, but a negative plus a negative gives us a negative. Now we need two numbers that multiply to give us 4, a +4, but add to give us -5. So that would be -4 and -1, okay? That gives us our +4b squared. There's a -4ab and a -ab. So if we have -4ab and a -ab, that gives us our -5ab, okay? So just because there's A's and B's, just because there's a b squared there, that just means we're gonna have this b over here to give us that b squared. As long as this has both A's and B's, we're good to go. See, these are pre-planned, so they'll work out, okay? It's harder if you look at it and you don't know that it will factor. They don't always factor, right? These numbers are really specific so that they will come out to be pretty little numbers over here. Okay. Recall that factoring out -1 from a polynomial changes the signs of all the terms within the parentheses, right? So from here to here, right, all the terms got switched. So we had a -x², now it's positive. We had a +x, now it's negative. There was a +12, and now it's -12, okay? All right, let's see. So identifying a prime polynomial. Let's we'll watch this lady's video. Luckily this section is pretty short. So we have time to watch a little video here.
In this video, we need to factor the trinomial x² plus 6x minus 8. Since the leading coefficient is 1, I'll set up two binomials, and the first term of each binomial will be x. Then we'll look for two factors of -8, whose product is -8, and whose sum is +6. Well, let me list all the pairs of factors of -8. We have -1 times +8. We have -2 times +4, -4 times +2, and -8 times +1. The sum of the first pair of factors is 7. The sum of the second pair of factors is 2. The sum of the third pair of factors is -2. And the sum of the last pair of factors is -7. None of these choices gives us a sum of 6 for the middle term. So we say that the polynomial is a prime polynomial.
Just like you have prime
that is, the
numbers,
polynomial is not
you have prime
factorable
polynomials.
with the techniques learned thus far.
So you can't factor that one. Not with the skills you have, right? Yeah, it's a prime polynomial because I mean, what it is you'd end up with like square roots of 2 and stuff. You know what I mean? If you step out of just the integer numbers, you can factor it. But we're interested in the trinomials that have integer numbers here, 13 and 14. Those are integers, and we're interested in the ones where we can factor, where you get x plus an integer times x plus an integer, right? But all polynomials aren't that way. Some of them are prime in the sense that if you were going to factor it, you have to step outside of the integers. You're going to end up with square roots of 3 and square roots of 5 and stuff like that. Okay. So you saw how she identified like this is a prime polynomial is because you can't factor it. And the way she showed you can't factor it, she looked at all the possible integers that multiply to give us the 14. So let's look at an example here. Let's see this one. If we try to factor this guy, I don't know, it might be factorable, maybe not. Yeah, it looks like it's factorable. We need a positive here, but this needs to be negative. So we need a negative and a negative. And if we will, we could try, right? If we did negative 14 times negative 1, that would give us positive 14, right? But they add to give us negative 15, right? We could look at negative 7 and negative 2. They multiply to give us 14, but they add to give us 9, right? And let's see, there aren't any other integers that multiply to give us 14, are there? If we did a negative 14 and a positive 1, negative 14 times a positive 1 is negative 14. This is a positive 14. See what I mean? So they make it look like, oh, that looks factorable because you're like 14 and 1, you know, the difference between, but it doesn't work out. Nope. Because negative 14 plus a negative 1 is negative 15. And negative 7 plus a negative 2 is negative 9. And neither of these are equal to negative 13, which is what we need. So this is prime. Does that make sense? There just isn't a number combination. So we'd have to step outside of integers and use some ugly numbers. So this one, if we try this one, we need an X and an X. And again, we have a minus and a positive, which means we need a negative and a negative. Because two negatives multiply to give us a positive, but two negatives add to give us a negative. And we look at 28, we could be like, okay, negative 28 and negative 1, right? They multiply to give us 28, but they add to give us negative 29. We need a negative 7. So let's look at another option. We got negative 14 and negative 2, but they would add to give us negative 16, not negative 7. So if we keep going, 4, what's 7 times 4 gives us 28, right? Yeah, but they add to give us negative 11, right? 6. I think that's it. So there are no number combinations that give us this. So prime. All right, so that's 14.2. Now we're supposed to skip to what, 14.5? All right. Well, since we have plenty of time, let's go ahead and do some of that. Maybe that'll give us some time for review, you know. Two, 4. Difference of squares and perfect square trinomials. Okay. All right, difference of squares. What they're talking about is if you have something that looks like this, something squared minus something squared, that always factors to look like this. A plus B times A minus B. See, you get your A squared, you get your negative B squared, but you got a negative AB and a positive AB. And so those cross terms, the middle terms cancel out. So anytime you have something that looks like something squared minus something squared, you can always rewrite it as something plus the other thing times something minus the other thing, okay? So let's look at an example here. So these are the easy ones. When you see, when there's no cross terms, it's always nice. All right, so we have these different methods, right? Factoring out the greatest common factor. We could do the 4-term polynomial by grouping. All right, we did that last time. Okay. Factoring trinomials by the AC method or by the trial and error method. I'm thinking that's what we just did. They have different names for these things. Is that what it's called? Okay. Okay, so we didn't do that. So, nope, didn't do that one. We did these two though. All right. Oh, and these things are called conjugates of one another. All right, see those things show up a lot in math. So it has its own name. So factored form of the difference of two squares. So think about your numbers in the perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9. So if you see these numbers, then you know, it's like, oh, I can use difference of two squares rule. Really, you can do it with any number, but then you'd end up with square roots. Right? And same thing goes with the powers of x's, all right? All right, this is important. So it doesn't work only with x squared. So if I have x squared minus 4, that's the same thing as x squared minus 2 squared, which means this is x plus 2 times x, not 2. Yeah. X plus 2 times x minus 2. Okay. There's my negative 2 squared or minus 4. And there's my x squared. I got a positive 2x and a negative 2x. So the single x term goes away. What if I had x to the 4th minus 4? Well, x to the 4th is x squared squared. So this would be x squared plus 2 times x squared minus 2. You see, I get the x to the 4th and I get my minus 4. But I got a positive 2x squared and a negative 2x squared. So that middle term here is x squared, okay? So it doesn't just have to be x squared, you could have x to the 4th or even x to the 6th. That would be x cubed squared, okay? All right, this is x cubed times x cubed. You got six total x's, okay? See ya. So we'll do one example of this and then we'll get out of here. I'll work the exam before I leave. 14.5 is what this is. So this is y squared minus 5 squared. So this would be y plus 5 times y minus 5. This one is 7s squared minus 2t squared squared. All right, you see that? The 2 squared gives us the 4. The t squared squared gives us the t to the 4th. So this would be 7s plus 2t squared times 7s minus 2t squared. Difference of two squares. All right, this is something squared. this is something squared. This one, don't forget, first thing you want to do is pull out your GCF. Both these are divisible by 2, and both of these have a z. So if I pull out the 2z, I'd need a 9w squared and a minus 1. All right, so this times this gives me this. This times this gives me this. So first thing, you pull out your GCF always. Now, this is the difference of 2 squares. I still have my 2z, but this is 3w squared minus, and 1 is the same thing as 1 squared. So I still have my 2z. This is the difference of 2 squares. So that would be 3w plus 1 times 3w minus 1. Because it's something squared minus something squared. So it's the first thing plus the second thing times the first thing minus the second thing. Okay. I think that's enough for today. We'll pick up on this next time. I don't want to make your brain ooze out of your ears.
Yeah, the time when I actually am like full of energy or not tired, that's
Well, we can keep going if you want. I don't mind. Or we can review. Well, you can work on your exam here. You know. So that's it for the lecture today, folks. And I will see y'all next time. For those of you here, we'll work on this exam and math homework. See you later, Nando.